KenGen, or the Kenya Generation Company. He is been an executive, right, or the executive director actually at KenGen. He's been an executive there for 11 years, and he was he was responsible for policy direction and legal drafting, right, formulating, negotiating, and operationalizing power and energy purchase and some of the steam sales agreements. So that sounds like a lot of very exciting stuff that could come out of that presentation today. Yeah, so we're going to hand over to Mr. Simon Ngure.
Good morning. My name is Engineer Simon Ngure. I am the chairman of the board of the Association of Electric Mobility Development in Africa. We are in Nairobi, Kenya, and this morning we shall be talking about switching for sustainability and investment in electric mobility. This is a case study for Kenya. We shall be sharing this information, hoping that we shall incentivize the growth of electric mobility in Africa, and especially in Kenya, because this is where the world has to go. The Association of Electric Mobility Development in Africa is domiciled in Nairobi and accepts memberships of all organizations that have either a commercial or other interest in electric mobility. Our vision is to be the leading Africa's resource for knowledge, networks, and support of electric mobility solutions. Our work is to support knowledge, innovations, investments around electric mobility, and this is towards low emissions in the transport sector, and especially across Eastern Africa and African economies. The reason why this is critical is because we do know that something has to be done about the emissions levels in the world, and we have to do our part. The second reason is that we do know that we do have lots of energy available that's not being properly utilized. We have existing market forces, and in the push part, we have the Climate Change Act, which has now been adopted by many countries, stemming out of the Climate Change Agreement of 2016 that was signed off by over 100 nations in Paris in 2016. Following that, a lot of nations, including Kenya, has signed nationally determined contributions with the United Nations Forum for Climate Change. In Kenya also, we have set up a strategy for national energy and efficiency conservation, and for energy conservation. We also have an Eastern Africa climate change policy. Again, it is important to understand that this is possibly one of the biggest reasons why electric mobility has become so attractive. Going on to the poll, in Kenya, we have the Big Four agenda. That is a government policy to drive a number of issues that are all interdependent with energy. In Kenya, we also have low off-peak power use, which means that a number of the power stations that are in Kenya are trimmed off at night, and we do not have them operational. That reduces the amount of energy consumed at night, and it makes that energy available for charging electric mobility units. We do have also an opportunity to connect this to affordable clean power, and in Africa we also have recovering economic sectors all across the nations. Going on, what are the handles? We do have challenges in Africa concerning policy frameworks around EVs, and these are still being developed. A number of nations, including Kenya, have started working on policies, but we do know that we have a number of nations in Africa where that has not started yet. We also have a challenge in public charging infrastructure. This is an area which needs lots of investment. And this is one of the more serious handles. In Kenya, we have a situation where all the EV manufacturers for vehicles do not want to come into Kenya because we do not have a charging infrastructure. And because of that, they do not see how their products will become popular. Because of that, they are holding back, waiting for the government to move ahead with this. The third hurdle is that we have low awareness and technical capacity within the nations of Africa. In Kenya, we do not have any training available that is standard for electric mobility solutions. Because of that, we have a situation where even those who are willing to change from gasoline motorcycles to electric motorcycles are fearful that they will not be able to access technical support because there are no technicians available in the cities of this country. We also have a challenge in that investors are running low on investor confidence. They do not know how big the market is going to grow, so they are fearful to put their money in either infrastructure or even the solutions themselves. So these are the challenges that Africa has to address. In Kenya, we're just starting. We have less than 200 units across the board that are electric solutions for mobility. They begin with motorcycles. These are the place with the highest number, 118. This is also the fastest growing part because we do have now a company in Kenya that is assembling 100 extra units that should be ready by the end of October. And we do have also a proposal to assemble another 200 units by the end of this year. So that's quite a quick growth. We also have a number of station wagon vehicles, mostly from Nissan, 28 of them. We have a few three-wheelers, and 22 units are already operational in Kenya. We have a number of forklifts. These are being used in industries, and that's quite a sector that's growing slowly, 21 units. And we have one electric tractor in the country. So what's the government doing about this? The government of Kenya has taken a position that they will use electricity available as much as possible to charge electric units. They also want to reduce on fuel imports. And because of that, they are encouraging transportation to switch to electricity. In Kenya, baseload electricity is available from geothermal sources and also from hydroelectric sources. So the country has an opportunity to use steam from the ground to run turbines that generate electricity in Kenya, and that does not need any fuel. So Kenya sees an opportunity to reduce the fuel import budget so that we can switch to geothermal energy. The other reason or the other effort that the Kenya government is putting is to change the vehicle registration process so that the electric vehicles have at least an easy way of identification and to put in road safety modalities to help with identifying these vehicles so that we do not have an issue with accidents, because most of these solutions are silent as they move across the roads. So that's something that's important, and the Kenya government is working on that. In regard to environment, we're working on emissions reduction and trying to do calculations on exactly what the emissions will be so that we can monetize that in form of carbon assets. And finally, the National Treasury is looking for ways to reduce the financing gap that they will have, because we do have lots of taxes on petroleum products that are used by vehicles on the roads. And so the National Treasury is going to have charges in financing maintenance of roads and such other activities. Because of this, they have to look for a solution to reduce that financing gap. And what's happening then is that the government is progressively working on policies to ensure that they have line of sight in each area, so they don't just develop a climate policy that is going to bring in electric mobility solutions that will impact negatively on the financing policy. So they are progressively working on that. And they're using the different silos to ensure that what happens in one silo has line of sight with every other sector. The second thing is, as I said, emission trading. And in Kenya, we're working on developing a solution at the Nairobi Securities Exchange so that emissions can be traded locally. This is something that the government is working on, and we have had a pilot that's going on in Kenya, and we do hope that in 2021, this trading platform is going to kick off. In the meantime, of course, the government is trying to ensure that we're keeping within our nationally determined contributions, and at the same time looking for new opportunities in the area of electric mobility. And finally, the government is looking for investors in putting in charging infrastructure. We do know conversations are ongoing with the distribution public utility for electricity, the Kenya Power and Lighting Company, to take up a front seat in this effort. So what's happening then is that we have a roadmap where we are developing standards. All of them, we have 22 already done, and we are working towards safety, towards integration, and towards improvement in a number of areas which will need to be done so that we can have a proper system operational in Kenya. What's happening also is that we have regulations being prepared right now to regulate importation and taxation, registration of EV units, and also in insurance. A coherent manufacturing assembling system, because we do not want to import things that we can be able to manufacture in Kenya. So we already have quite a bit of work going on in this area, but it's the next frontier in the days ahead. The standards are already available. 22, I said. I think I have 21. One just passed as we were preparing this presentation, and that enabled 2 companies to get permission to do local assembly. And that's already happening in motorcycles, and 2 companies are already cleared by the standards organization to proceed with that work. And we have focused on performance, safety, and testing, as I mentioned at safety area. And we have now covered electric motorcycles, mopeds, and road vehicles. The next steps will be to move on to standards for road safety. These will be visibility and other safety issues, operations, performance, and test procedures. In regard to operations especially, we want to ensure that we are able to gather data from across the country for all operating units, so that we can use that data to determine how that market is progressing and what advantages we are getting. That will also help us in carbon accounting because we will know when each unit is mobile, how many kilometers it has covered, and how much fuel consumption has been avoided. We are also developing standards for hybrid electric vehicles, and also focusing on motorcycles, because motorcycles, as you may already know, have a huge economic and environmental impact. Economic in that this is the solution that most rural areas are using. And environmental because they do use a mix of fuel, petrol, and oil. And so the emissions from these units have a heavy environmental impact, of course, negative. We are also finally working on standards for locally manufactured vehicles. What are the opportunities, therefore, that are available? The first is to convert existing motorcycles. We have a potential of converting up to 1 million units in this region, but then we are having about 105,000 units coming into this market every year. So because of that, we do have a market potential to convert many of these units. The second opportunity that we have is to convert existing motor vehicles. We do get into Kenya 90,000 units every year, and we already have over 600,000 units that can be converted easily because of their age and also because of their utility. We do have, as I mentioned earlier, 2 companies that have been approved to convert motor vehicles and motorcycles. One of those companies has already done over 15 motor vehicles, which are used in the hospitality industry. The third opportunity is that we have an opportunity to bring in completely knocked down units for assembly in the country. We also have an opportunity to recycle combustion engines and recover steel and aluminum that can be used for other needs. And finally, we have an opportunity to do battery recycling and deployment into second life applications like in homes. So these are the opportunities that are available in Kenya right now. Going on, we have infrastructure development. We mentioned this area. It's sort of like the next higher tier opportunity. Developing vehicle charging stations in residential and public settings, in commercial buildings to incorporate charging infrastructure. And we also have opportunities in battery swapping for the 2- and 3-wheeled vehicles. We also have opportunities in deploying electrification in the bus rapid transport system that's being designed for Nairobi. And also, we do have a new standard gauge railway network being developed with the sections between Mombasa and Nairobi already done and being in use. All the units on this railway network are electrification ready. And so what's needing now is to put in the electric infrastructure along the railway line. Also, we do have grid upgrades that are needed to accommodate the growing demand, and that's being undertaken by the Kenya Power and Lighting Company in Kenya, which is in charge of electricity distribution. We finally have an opportunity to adopt non-motorized transport methods by converting bicycles to e-bikes. All these are available opportunities in Kenya. We also have opportunities in capacity building, technical training for technicians, artisans, and engineers, and we are working on what kind of courses will be available. We also are looking at education for non-technical professionals in finance, accounting, the rigor of fraternity. We're also working on a university research program for local solutions. In addition, we're looking for adopting IT innovations into the whole value chain for vehicle monitoring, integration with financial services, and other uses. And the reason why I mention financial services here is because we already have one of the solution providers in Kenya for e-mobility giving away or lending motorcycles to riders, and they pay per kilometer that is covered. So they don't need to own the motorcycle or the batteries. They just pay for kilometers that they use the unit on. So how is the Association of Electric Mobility Development in Africa helping? It is helping to become a respectable voice with governments, not just for progressive economic propositions, but also to bring to the knowledge of government possible ways forward for developing this market. We also are undertaking market intelligence across high potential countries in Africa. We've done one in Kenya, one in Uganda, one in Ethiopia, in Nigeria, and there is one going on right now in Ethiopia. The Kenyan report is going to be available not too long from now, and you may be able to access that on our website when it's available within a few weeks. We're also connecting financiers to investors, those who are willing to do something, but they do not have the finances. And we are collaborating with financial institutions, with the government of Kenya, and other stakeholders like the electricity companies in Kenya, so that this can be available, the electricity can be available, and that the government can offer tariffs that will incentivize these solutions, as well as import rebates, so that getting into this sector, into this new switch area, is not going to be too expensive for the people that are wanting to come in. And finally, IAMDA has working groups where members come together to discuss self-regulating, so that we do not have to be regulated by the government at the very beginning, and so that we can be able to give the government the best regulations, which are best practice in the industry. We will stop here by stating that we're ready to transform Kenya and transform Africa by bringing synergies across all the areas needed to be interconnected for ensuring that electric mobility in Africa develops at the fastest pace. And what we have shared today is the Kenyan case study. Again, let me thank you for listening to me. You can reach out to me on my email, and on this slide I have my telephone as well, and you can reach out to our directors who are working in the Association of Electric Mobility Development in Africa. Thank you very much, and we do hope that we'll be able to answer your questions coming straight up. Thank you.
Thank you very much, Mr. Simon Ngure. Wow, there's too much opportunity in Kenya. I'm actually even thinking I should just pack my bags, book the next flight, and just head out to Kenya and open an e-mobility business. I don't know what we're gonna do, but there seems to be a lot of opportunity. If we're not creating charging stations, we're gonna swap out batteries or something. So thank you very much, Mr. Simon Ngure, for that information. And yeah, I really enjoyed hearing about the work that you guys are doing in the Electric Mobility Association. And hopefully we'll be able to see more of your work in the near future. Okay, I think now we're gonna move on to the next speaker, if I am correct. Okay. All right. So our next speaker is a local gentleman, here from South Africa, Mr. Highton Palmer. Right, Mr. Highton Palmer. I've personally never met him face to face, but Mr. Highton Palmer and I have spoken a lot via email, and I'm very excited to see his name on this list of speakers today. Mr. Highton Palmer stands as the lead executive and thought leader and industry expert, right, extending over 15 years in profession. As the director of the South African National Energy Mobility Program, right, he delivers the mandate to enable, facilitate, and mobilize electric mobility through multi-stakeholder engagements across the public and private sector. Right, and he does this both locally and he does it internationally. Right, so Mr. Palmer then encompasses, right, with a master's degree in electrical engineering and an honors in business administration. Right, Highton's passion extends across contributing to technological advancements within the industry globally through the deployment of interventions to solve major economic, competitiveness, and social challenges. So I personally am very excited to be hearing from Mr. Highton Palmer today. And I hope everyone else who's in this session will learn as much as I've learned in the time that I've known Mr. Palmer, and be able to take away some very interesting insights on the South African market and also the global market. So without further ado, I'd like to hand over to Mr. Highton Palmer.
Good day, ladies and gentlemen. It's a pleasure to share the platform today online in the midst of new developments and efficiencies as well. The topic of presentation is the electric vehicle system and energy efficiency opportunities that electric vehicles present. I am Highton Palmer, Director of the National Uyilo Electric Mobility Program, that has been active since 2013 on enabling electric mobility in South Africa. So if we go straight into it, looking at the electric vehicle forecast, there's certainly a exponential growth globally that is highlighting the introduction of electric vehicles into the markets globally, but then also a radical uptake in the EU on new vehicles being electric and new models being introduced, as we see on our right-hand side on the screen. With that, South Africa imports its vehicles, majority of from the EU, and hence, as these models are introduced or manufactured in the EU, we aim to see that introductions coming into South Africa. What is important to note on the slide as well in terms of technologies, on the left-hand image is we note that battery electric vehicles still maintain a larger portion of the market share, with plug-in hybrid vehicles coming into play second, and then a growth of fuel cell electric vehicles in that space. The aspect of transportation becoming electric, it's across all modes of transportation. All modes and options will be fully electric, from personal mobility to passenger mobility to motorsport, commercial vehicle applications, public transport, marine and aviation is moving to electric. So as we see this moving with efficiencies and technologies, it's quite predominant that transport will become electrified. It'll be connected into the Internet of Everything. It'll be multimodal, bridging different modes of transportation. It'll become shared in terms of the new modes of operation of customers and experience. And the future will be autonomous, where vehicles themselves will aim to drive themselves on different mobility platforms as well. Now, looking at efficiencies, what's noted on the right-hand side, moving to the left, is that the traditional conventional vehicle from internal combustion engines, if we look at energy, the generation of the energy itself and production of the fuel, if that's coupled to renewable energy, we look at the fuel production efficiency is only 44%. and once utilized within the vehicle, is only 13% efficient at the output of the wheels. Moving into the middle, unpacking hydrogen, the fuel production increases to about 52%. However, the optimization and utilization in vehicles provides an efficiency of up to 22%, so not still ideal in that essence. However, looking at battery electric vehicle technology from an efficiency perspective, if you look at 100% renewable energy generation, we're seeing that production of the energy itself is up to 95% efficient. And then on utilization on the vehicles themselves, it is then becoming 73% efficient. So from an energy efficiency perspective and the focus of the conference as well, we realize that battery electric vehicles are certainly a lot more energy efficient from energy input to energy output across the value chain of other technologies in the additional technologies as well as emerging technologies. So unpacking that further, I think what electric mobility is also brought about, it's not only an energy efficient vehicle, as in the mobility platform, but the whole value chain in terms of production is becoming efficient. With that, they're looking at new material development into the vehicles, being sustainable and efficient, and also the method of production of producing these vehicles. The factories themselves are moving to renewable energy. The automation within the factories are also moving to smart systems and energy efficient systems. And optimization of efficiency as a whole from a production environment and optimization of the systems as a whole. So with that, we see merging into Industry 4.0 and to Internet of Things, all in the space of energy efficiency and optimization as well. So it's not just a product as well, the whole value chain of production as well as material sourcing is moving to sustainable and energy efficiency. With that, it's also looking at the end of life in terms of vehicle recycling, making sure that materials that go into the vehicles are sustainable and able to be recycled as best as possible. So when we look at the life cycle of the vehicle, how efficient are they from a total vehicle life cycle? Well, it's clear here as well from not only utilizing the vehicle, but the efficiencies that these bring across. So the example here is within the EU. On the stats presented, that today's petrol and diesel cars emit almost 3 times more than the average EU electric car. That is taken in terms of the averages and countries presented there. So it's clear that electric vehicles, not only from the direct usage, emit less CO2 from the tailpipes, they eradicate tailpipe emissions, but also dependent on specific countries where they have high renewable energy production. The overall total emission life cycle is a lot more or less. When we're looking at it from a user perspective, this is a snapshot of the maintenance of a traditional petrol vehicle versus a electric vehicle, specifically both vehicle comparisons from Nissan. So with this, we've spoken about the efficiency of the vehicle, but this is some efficiency in your pocket as well. So what we're seeing in the top is a typical maintenance cycle of a petrol vehicle. And with that, you're looking at the total life cycle or maintenance cycle of the vehicle of up to 150,000 kilometers. And what we note there is the R, which is actually replaced, but in South African context, it actually rands in retrospect on that, because every time they're going to replace all of those components, you're going to be billed for that in somewhat format, either in a maintenance contract or built into the price itself. And with that, we're seeing that on a petrol vehicle, there's quite a bit of maintenance in there involved over the life cycle of 150,000 kilometers. However, looking at the image at the bottom, we're seeing an electric vehicle is a lot more efficient from a maintenance perspective. The I that is highlighted there is just on inspection. So what we mean, what this is highlighting, that is over a distance, a usage distance of 150,000 kilometers, a electric vehicle would typically only go in for inspection and not have additional components to replace, and thereby also providing a efficiency in terms of your pocket on maintaining and utilizing an electric vehicle. So moving on to the vehicle component itself, what we see is the main component highlighted there on the floor of the vehicle is the battery. That is the key component of the vehicle, where majority of the technology is coming into play. but then also a huge cost of the vehicle itself. Thankfully, the manufacturers offer up to 8 years warranty on the battery, and that gives some consumer protection and confidence in the vehicles themselves. The battery is also the largest component in terms of the electric vehicle drivetrain in the system, and typically takes up most of the space on the floor of the electric vehicle itself. Now, moving on to the technology of the battery, and that's what electric vehicles present. Within electric vehicle, as highlighted earlier, a large component is the battery. Essentially, electric vehicles present a battery on wheels. And in the energy space, we're seeing energy storage play in the mix of renewable energy generation. The energy demand is not always at the peak of energy production from renewables, and hence batteries or energy storage technologies coming into play. So if we latch that onto electric vehicles, what we see is an opportunity to utilize electric vehicles beyond just mobility or transportation. What we see is then utilizing the application of lithium-ion batteries for grid services, behind-the-meter services, and those opportunities there. So typically what we see over in the slide is how the landscape of the energy sector on how they utilize batteries, and typically specifically lithium-ion batteries in that way. So if we unpack that going forward with the car, what we then, as an extension of the energy sector, we see the technology landscape evolving. What is traditional from a central generation, transmission and distribution, we're seeing an evolution come into play of new technologies coming in, which are bringing efficiencies as well from a generation perspective. What's also key to note in this space is also energy storage that's also playing from bulk generation into transmission, distribution, and end user as well. And looking at the end user slide or image, what's key to note on the right-hand side at the bottom, microgrids come into play, and also transportation. And on transportation, the image shows a bi-directional arrow, meaning that electric vehicles will not only charge from the grid, but able to support the grid as well. And this is on the basis of expanding the aspect of the batteries within the vehicle. So the supporting infrastructure that allows that to happen, there's a range of different types of charging stations that get utilized at home, at work, and on the road. And what we also see is new technologies of charging stations coming on that have onboard storage. So basically what it means is that when an electric vehicle is not being utilized on the charging station itself, the onboard energy storage system in the charger will actually charge up. And when a vehicle comes, it's able to deliver full power with minimal impact on the grid. So we're seeing supporting infrastructure available on public transport. We're seeing vehicle to grid come into play, where vehicles participate within the energy system while they're lying idle. And then what's also important to note in terms of energy efficiency and minimizing the impact on the grid is the implementation of resilient and smart grid infrastructure that supports renewables, that supports storage on site, and minimizing the impact on the grid, while also optimizing energy efficiency. And in South Africa's case, while the grid is carbon intensive from predominantly coal, these sort of concepts provide energy efficiency on the grid edge side in terms of optimization and minimizing grid impact. So with the technology as well, if you look at the image on the left, typically uncontrolled charging, both on the vehicle and the infrastructure systems, we will possibly strengthen or impact, have a high impact on what's termed as the duck curve, on where electric vehicles will typically charge also in the evening as they get home. However, through the utilization of smart charging and vehicle-to-grid technology, we can actually flatten those curves and optimize both in the as well as on the back-end systems that control the charges, on optimizing that from a supply and demand perspective. So with the full integration of the system into the utilities such as ESCOM and the municipalities, where they are generating their own energy, we then see that electric vehicles demand on charging can actually be controlled and optimized to when there is capacity, and essentially flatten what was called the duck curve into a typical camelback curve, as the impact on the grid network, and also improving energy efficiency overall, optimizing both supply side and demand side management. So on infrastructure services, what's called vehicle to everything. As mentioned, the electric vehicles have a large battery pack, and through that, utilizing the technology of the vehicle, the hardware of the charging infrastructure, as well as the software as the infrastructure, the vehicles themselves are able to deliver vehicle-to-grid services, typically looking at voltage regulation, frequency regulation, and other services as well. In the context of energy efficiency, in homes that are energy efficient, typically production home rooftop solar, with rooftop solar, we can then utilize that on energy production, and then on-site energy storage as well. And then also expanding that on with electric vehicles that will increase the storage capacity. And typically that will form what's called vehicle to home, and typically behind the meter services, where the electric vehicle will supplement the storage technology and ability to minimize energy production and energy utilization in the home environment. The technology utilization on V2X, or vehicle to everything, is being expanded into different technologies, not only DC technology, but also AC technology, and a number of manufacturers also participating in this technology as well. While it was being pioneered by Renault, Nissan, and Mitsubishi, we're certainly seeing new OEMs on vehicle manufacturers coming into play into the technology itself. So expanding on vehicle to everything, and really increasing the opportunities what electric vehicle presents. Typically, we've got vehicle to grid. That's when fleets of electric vehicles supplement and support the grid in terms of ancillary services. You've got vehicle to building, where fleets of vehicles will connect into a building and also provide behind the meter services and energy optimization. And vehicle to home, in an energy efficient home, supplementing the energy demand with the storage capacity that's available within the battery. And typically vehicle to load, in situations or circumstances where there's full power outages, in disasters or any other situations, the technology of V2L will allow power to be dispatched from the vehicle into a device that can provide typical 220 AC output and power typical loads for any type of emergency relief or support in that regard. So if you look at vehicle to projects worldwide, there's certainly a number of emerging and leading projects globally, specifically in the EU, in Europe, where a lot of the technology development and piloting is taking place. That's also led through the charging technology of Shademo, which is on the Asian vehicles, but we're seeing that also come into play now from specific pilot projects from the European Association as well, and supporting technology. And through that, we see one of the projects specifically highlighted is the UILO project on the smart grid ecosystem for electric vehicles. And through that, we see the showcase in South Africa on energy efficiency and optimization, minimizing the grid impact on EV charging, optimizing renewable on-site generation, coupling storage, not only traditional storage in the context of repurposed electric vehicle batteries onto stationary storage and integration within the circular economy. And what we see is a large distribution of multiple charger network, AC charge points, DC charge points, the technology of vehicle to grid, as highlighted earlier, being showcased alongside Nissan, and then also energy management, localized energy management, optimizing energy generation, monitoring the grid on what its capacity is, and also optimizing the demand side from the chargers as well. And then on the overall smart grid communications, that's the project has alignment to IEC 61850 for remote smart grid communications of the microgrid itself. So what we see is that there's local demonstration of these technologies in South Africa to advance the rollout and support all role players in the ecosystem as such. So wrapping up from UILO's side, as mentioned, the program has been in existence for the last 7 years, alongside a mandate of enabling, facilitating, and mobilizing electric mobility. The program is supported through the Technology Innovation Agency and funded through the agency as well. The activities of the programming could include government lobbying, industry cohesion, enterprise development, pilot projects, thought leadership, and skills development. program is supported across the ecosystem of electric mobility as we see that it presents. So it's not only about the vehicles, it's unpacking the whole ecosystem in South Africa, looking at new technology developments, supporting mobility options, skills development, and also unpacking the circular economy, and is supporting facilities as well on enterprise development support, on technologies and emerging participation of the industry as well. On Kickstart funding, that's what we initiate to advance industries in South Africa to participate in that, and that's an annual funding call that's available to advance technologies across the ecosystem for electric mobility, and also advance South Africa's participation not only in the local economy, but also opportunity in long-term outlook to expand and participate in the global economy and technology that electric vehicles present. So finishing up on South Africa, where are we? So hybrid vehicles were introduced in 2005. So it's still early days for electric mobility, but certainly we see an uptake coming into play, and various lobbying work that is in play to try and assist the uptake from a pricing point of view, from a taxation point of view, and trying to increase the uptake of electric vehicles. Supporting charging infrastructure is growing radically across the country. A number of role players have been advancing that, and we're seeing that not only within the urban and the city environments, but we're also starting to see the network develop on the highway networks as well. And as alluded in introduction, it's not only your personal mobility. All modes of electric vehicles are being showcased in South Africa in mining, on commercial vehicle applications, electric motorcycles, as well as tourism and utility vehicles. So we certainly see South Africa is emerging in this space. A lot more commitment and implementation is required, both from government and industry. And we hope that this has certainly brought some insights to the delegates of the conference, and we look forward to further advancements and uptake of the technology itself. So thank you for your attention, and hope that that has brought some insights and opportunity to engage further in the later panel discussion. Thank you.
Okay, sorry guys, hey, this online thing, it's complex, it's not for everyone. So I'd like to apologize for that. I had my mic on mute. Yeah, so to start again, thank you, Mr. Palmer, for that highly informative presentation, on giving us an update on some of the efficiencies, some of the technology, and the state of where South Africa is sitting or standing in the global context and in the local context when it comes to e-mobility. I think a lot of people have learned a lot from what you presented. For myself, and judging by some of the questions that we are getting in today, a lot of people are really excited about where South Africa sits in the e-mobility and the future and the potential that the future holds. As you had indicated, that it's still very, very early days for the South African e-mobility industry. And yeah, let's hope that the government does give you more of that funding so that you can help some of the startups that are trying to break into the local e-mobility industry and in the global industry as well. So thank you very much, Mr. Hayton Palmer. Now we're going to be moving over to our next speaker. Now, this speaker doesn't need much of an introduction, but because we have to stick to formalities, I'm going to introduce him. The gentleman's name is Mr. Winston Jordan, right, who's from Grid Cars. Now, if you've been following the South African e-mobility industry as well as I have, then this is a name that definitely doesn't need an introduction. Mr. Winston Jordan has a degree from Rose University, right, in maths, physics, and computer science, driven by his passion to understand the future trends of energy and mobility. Winston, along with BMW, Nissan, and Sanedi, was a founding member of EVIA, which is the Electric Vehicle Industry Association. He has recently successfully rolled out South Africa's most extensive EV charging network, including the grid cars and the Jaguar National Powerway. As an accomplished speaker, Winston has presented at conferences on various aspects of innovation, development, and future trends in energy, both in generation and consumption, as well as the technology behind electric vehicles and associated support systems. Winston has recently been involved in various commercial projects, including developing business cases for renewable energy, research and development of commercial commuter electric cars, and the promotion of smart grid connected systems such as electric vehicle charging infrastructure and back office system. So without any further ado, I would like to hand over to someone who I personally think is the godfather of EVs in South Africa, Mr. Winston Jordan.
Hi, how are you? I just want to share my screen because I'm presenting live.
Sure.
Share. Okay, is that visible to everybody? Just let me confirm.
Yes, it is.
Great, thank you so much. And thank you for that introduction. It's the first time somebody has referred to me as a godfather. I have my own beliefs on the godfathers in South Africa, and that's guys like Peter Langley that have really driven this industry over the last 20 years, Carl Snyman. These are the real godfathers. So I sort of look up to them in terms of where they're going. But let me tell you a little bit about what we have done in South Africa. So just as a very brief introduction to what grid cars is, we play in 4 functional spaces. So firstly, we're a charge point supplier. So we've got a range of charging stations that we would be able to sell or supply customers. We are an operator, so we manage charging stations on behalf of other customers. And we're an e-mobility provider. An e-mobility provider means that we're really managing the back end of the charging station. So the back office, the payment systems and the billing systems. And then finally, we also invest in the network and help to grow that network so we can move that across South Africa. Why is the EV market growing? I think Hidden has given us some really great insights into where the market is and to what the world players are, etc. So these 4 major drivers. Firstly, stricter emissions on emissions regulations, and I think customer awareness of these regulations and certainly of the emissions side of things. Customer acceptance is really a big one. We're starting to see more and more people realizing where the technology is going and what's going to happen and when it's going to and how quickly it will pivot. Lowering of battery costs, that's a massive one in the market, and the installation of more charging stations as we expand that network. I think we're seeing the evolution of multiple business models in South Africa. We're seeing large players entering the market, so more and more of the fuel companies are putting strategies on the ground. Most of the OEMs have now got a strategy, if not vehicles in the country. We're seeing early signs of consolidation of technology. We're seeing venture capital and private equity funds starting to underpin the growth. And these are all the signs that you need to see a strong move towards the pivot within this industry. So there's also strong support from international and to some extent local levels of terms within decarbonisation. We're seeing a drop in price of renewable energy and lowering operational costs of EVs, and specifically international affordability of EVs and the increase in supply. And why do I say specifically international? EVs are still relatively expensive in South Africa, but as the prices drop internationally and as production internationally slows down, there will be a forced move to electric in South Africa, and we will need to manage that transition. So this is the motivation as to why we think it's all going to happen quite quickly. So part of the discussions that we've seen happening around various tables, and that is who's going to pay for the infrastructure. So there's 3 ways that ultimately this will play out in South Africa. It's different in other countries. In other countries, we've seen a much stronger role played by government. So if charging was free, the only people who are going to fund that are going to be the OEMs and government themselves. And they'll be paying for everything because there isn't such a thing as free. So if you're driving an electric car, it uses electricity, and somebody's going to have to pay for that electricity. So a free charging strategy would mean the payment must come through the OEMs, the government, and maybe to some extent property owners. If we look at a price-controlled environment, then again, the infrastructure funding would most likely need to come from government and OEMs, simply because there'd be very limited business cases. There wouldn't be the opportunity for entrepreneurs to enter the space. And certainly price control would mean that the EV customer is paying for the charge. Finally, is if we allow the industry to be driven by commercial rates. So supply and demand. Basically, as new players enter the market, there'll be a place in terms of price, and we'll see those things changing over time. Certainly there, you're looking at infrastructure funding through the entrepreneurship, property owners, OEMs, and various other opportunities, business models that come up. So just to then run into how do these things start coming together? So if you look at what a typical charge site would look like, there's the supply from the grid, there's the main transformer to step it down, then you go through a meter, into a DB board, an isolator, a charge point, and into the car. So this is the main line that we look at. In most cases, the existing infrastructure up to the DB board is sufficient. So therefore, you have a business as usual. It's really where most of our installations have happened, and where most installations today are happening in South Africa, is that the charge point owner would fund it from that point forward. Next is what we would call a ready-made installation, and that would be where the property owners are already, we are seeing with new builds, they are starting to prepare their DBs and wire things up to an isolation point close to where the charger will be installed. So when we come along as a charge point owner, we just have to do the final connection. And then certainly, owner-operator, and this is buildings and properties that are actually doing the full installation themselves. When we move to high-power systems, this line starts to move back towards the transformers. And just to give you an idea, if you've got a 200 kilowatt transformer and I want to install a 360 kilowatt charging station, we've got a problem. So we need to then look at upgrading those networks. As we look at constraints within these networks, because this is really where the challenges come in infrastructure. So the first level of constraint, we typically try and deal with that through what we would call smart charging or load management. Really, it's similar to what Eskom's load shedding is. So we'll share the load between various vehicles or various charging stations, potentially between various properties. And we'll manage that load in a clever way. So if we know certain cars need to be charged quicker, we'll give them some level of priority. So if we move into the second part of stress management, we start looking at having a battery boost. So battery systems that then boost the charging infrastructure so that we can slowly build up the charge in the batteries and then unload it when we need to actually charge the vehicle. The next level is we move the battery system to a battery backup at the site, and we'll probably start looking at introducing things like solar and allowing that site to be a little bit more independent and to be able to expand beyond the normal capabilities of what their site is capable of doing. Beyond that, it's really making transformers bigger. So, we want to try and avoid that because that becomes a very costly exercise. So does this really work? As Grid Cars, we work with a company, SolarF, who's one of our shareholders, and we get a lot of exposure into where the solar market is going and where things are going. So we took some real case studies and we just looked at what are these sites doing to be able to reduce energy. And if you look at this particular example, it was a hardware chain store. And their normal usage is the red line where you see at the top. You'll see the solar where that came in, and this is how their usage then reduced in terms of network, external energy consumption. So that gap can then be used to support charging infrastructure, and we can look at driving that forward. And this is really where a lot of real value comes in for bigger sites that can afford to put out much larger charging equipment and solar systems. Another example, we've worked with Clearwater Mall. You can see a small picture in the top right of it, but this just gives you some sort of idea again of how much contribution something like solar could make and how we could utilize that contribution going forward in solar systems and charging systems. So the next one, probably my most controversial slide today. My apologies, Hitten. I know this is one that you and I have lengthy debates around, and that is that the CCS versus CHAdeMO. Now, yes, these are two major standards worldwide, but as you can see, there's a massive bias towards one of those plugs, which is called CCS. It becomes a real challenge when you're rolling out infrastructure. Grid Cars was faced with, every single charging station supporting two standards means extra money. And if I look at the network we rolled out, we probably rolled out 5 or 6 extra connections simply because of the fact that we weren't supporting a second plug standard. So South Africa is lucky in the sense that we are a new car country only. We don't import second-hand vehicles. And because we don't import second-hand vehicles, we don't typically have to deal with legacy things. So Nissan, for example, typically brought out Shadimo initially, whereas now they are offering it, making it an offer that you could either bring the vehicle as a CCS or Shadimo. Clearly, at that point, you need to be buying a new vehicle, not importing second-hand vehicles. So I think as a country, it's really worked for us to stick to one standard, and Gridcars has supported CCS across the board and across the network. So just to then take you into what this operating environment looks like that we've already established here in South Africa. And I think it's really important to understand when we talk about infrastructure, yes, there's the energy side of it, there's the charging side of it, but there's a massive big virtual component to it. And Gridcars has partnered with IntDev, Catalytic, and with Internet Solutions to set up a massively redundant system where we have some data center redundancy, we have line redundancy. So it gives us exceptionally high uptimes of any of the equipment that we're running in these networks and able to be able to support that network. The second part of this becomes security. How do we manage the whole secure side around customers' data, around customers' movements, habits, etc.? You know, POPI controls that really strictly in South Africa, and Gridcars is in the process of going through certification for that now. So at the end of the day, you've really got to build the infrastructure around the protection of data. Specifically, when you're working with bigger manufacturers, you know, we work extensively with manufacturers like Jaguar, with Porsche, BMW, Audi, with any of the manufacturers in the country, and they have massively structured systems around what you can and cannot do with customer data. So we've really got to ensure that we have a system that is protected for that. To look at the overall picture of the back end, I'm not going to run through all of this picture. Really, it's just to show you 3 things on here. So the blue block, the dark blue block, is called the charge point operator. And the charge point operator is the portion of the network that is responsible for communication with the charging stations, maintenance of the charging stations, etc. The EMP side of it is responsible for communication with the customer and the payments and the billing systems. And then in the middle, you have a part called the aggregator. The aggregator is sort of the clearinghouse, the banking exchange. It's the third-party payment provider. It deals with all of the things related to banking and money, and very much a roaming platform as well. So it also deals, so similar to what you would see in the banking world, where you deal with BankServe or SASwitch in South Africa. So this deals with allowing multiple single cards to work across multiple charging networks. So as we move forward, how do we activate a charging station? If you arrive at a charging station and you want to be able to pay, it's really important that we try to keep this as simple as possible. If we allow the industry to move in a direction where we have 20 different payment systems, this is going to be a real challenge. So what we've done is to look and say, how do we drive a single payment strategy? And that strategy right now is RFID. But on top of that, if you don't have an RFID, you can start it with the app. There's an app that you've got that you get that allows you to start transactions, look at your transaction, see how much it's costing you, etc. You can also start it using a QR code or a WhatsApp message. So we've tried to integrate the single payment system or the single payment platform into various points of initiating those charging sessions. And finally, if you've lost everything, you've lost your phone, you've lost your card, well, maybe not lost your phone, then you can call into the call center and somebody will help you start that charging station remotely. So we're fully capable of really providing multiple layers that allows the technology to work. If we look at the value chain within this industry, what this drawing tries to do is just give you some idea of where the profit margins lie, or at least the profitable portions of this industry lies. So firstly, you'll see the green haze around some of the blocks. Obviously, financial services, banks, if they are funding something, they're making a profit out of it. Hardware sales is profitable. Installation and maintenance, it's profitable in the industry. Energy distribution, energy generation, all of those things are profitable in the industry. The point where the investments are coming is really, let's call it the red haze around the blocks, and that's in the owner of the charging station. They're investing heavily. And right now, they're probably investing at a level where the returns are less than 5%. So less than 5% of what it needs to be. So if you're looking at profitability within that portion of the industry, we need to see that a 20 times growth before it is profitable for an owner. So this is people that are really taking an early step in the space and working on it. Obviously, with sites that install and management of software services. These are also not profitable at this point in time. But if we don't have those, we don't have a managed system, and we don't have something that we can grow from and that we can build. So Gridcast has taken the initiative of establishing these systems and getting everything in place in such a way that we really are able to deal with that. So what does the network that we keep talking about look like in South Africa? So to give you some basic things, firstly, the first question that we're going to typically be asked is, what does it cost? So it's a difficult question. And the reason why, let me show you what's happening in the UK. So this drawing basically shows, if you look on the left-hand side, that shows the markup on electricity. So one would be 1 times the cost of electricity. So if electricity was £1, it would be £2. And so looking at where those numbers rank, the average in the UK right now is around about 3.3. So 3.3 times the cost of electricity is the funding cost needed to sell electricity in order to make the investment in infrastructure worthwhile. However, we're much, much closer to the 5 to 10% on the horizontal scale in terms of actual position. So what's happening is even the 3.3% is not at a break-even point. So if you just take a look at the big black line, that one is showing you the profitable point. So in terms of annual compound growth of energy use, we need to be up at 15 to 20% before we cross over that profitability point for even in the UK and areas like that. In South Africa, we're certainly a lot lower than that. But importantly, we've positioned the pricing because there is not a huge market. So we've had to position this very much on our own as Gridcast. And we've positioned that at 2.5 times the cost of electricity as a starting point. Beyond that, we would see how the markets develop, how other players entering the market would price their things. Some people will price above that, others will price below that. And that will allow the market dynamic to sort of move around and allow a fair deal for the customers that are working in the space. So what is the real numbers for South Africa? Well, if you look at a fossil fuel vehicle, I think I might be out on the fossil fuel price per litre because I don't buy petrol anymore, so I'd have to go and look it up. But if you look at that, we're looking at fossil fuel roughly about R1.50 per kilometre. If you look at public charging in South Africa, so this is charging on the Gridcast network or any other network for that matter, whether it be Jaguar or any paid network, around about R1 a kilometre. So that would make it 30% cheaper than driving on fossil fuel. If you were charging on your home charging system, so just paying the municipality's cost, you should be down at about 37 cents a kilometre, which is maybe a fifth of the cost of fossil fuel. And of course, if you move to solar, the solar business case really makes a lot of sense for electric vehicles. And that can take you down as low as 1.7 cents. So we talk about what we call blended rates, and blended rates for us, and that is that about 20% of charging would happen in public. I think there are worldwide stats that talk about 10 to 15%, so it could be as low as that. But we've worked on a rate of 20 for this example. So if 20% of your charging is done in the public space, then you're looking at about 44 cents a kilometre. So less than a third of the cost of fossil fuel. And if you bring in your home charging as being solar charging, then you're looking at about 34 cents on a blended rate. So these all show you very clearly that it is absolutely cheaper to be driving on electricity than what it would be on fossil fuel. Of course, it depends on the size of your car, and there's some variations around that. But this gives you some sort of idea where the pricing strategy is going to go in South Africa specifically. We looked at 2 scenarios to try and get an understanding of whether it's worth investing in the infrastructure now and trying to understand where do we take South Africa. The first thing, the idea was to say, what will happen by 2035? So roughly about 15 years from now. So the idea was in 2035, we need to look at 2 scenarios. Scenario 1 is that we stop selling fossil fuels by 2040. Scenario 2 is we stop selling fossil fuels by 2050. So this gives you some sort of indication of where we're going. 2040, personally, I think is actually wrong. It's simply stated. Some of the most optimistic projections that are coming out are saying we should be stopping selling fossil fuels by 2026. That's only 6 years away. And this is looking at rapid pivots. It's looking at things like the Osborne effect and how that's going to change the way that spending and the way that these things will grow. So, but let's be conservative and say it's 2040 that we're looking at. If 2040 is our stop selling fossil fuel date, then 2030, then what happens at 2035? Firstly, we would have to have a fleet of about 2.8 million electric vehicles already by that time. We would also need a total fuel service or fuel cars of about 5.2, because remember, they're not just going to disappear, they'll diminish slowly. We would have invested about 7.6 billion Rand in chargers. So the current investment happening in charging infrastructure is really low compared to that. So we've got to really pick up that investment strategy if we want to stay on track for a 2040 stop selling fossil fuels, which again, I honestly believe is way too late. We will be 5 to 10 years before that. And the cost of electricity at that point, and this is an accumulated cost, would be about 98 billion. And to put that in perspective, that's about a half of what we currently spend on fossil fuel. So it just gives you some sort of idea of where we will be positioning. If, of course, the stop selling fossil fuels moves out to 2050, again, I stress, finding a car at that time. No manufacturers, the rest of the world will be manufacturing cars. So I don't know where we'd get new cars by 2050. And then obviously all these numbers change a little bit lower. The investment would be roughly half the amount of electricity, about a third, all of these ideas. So this gives you some idea of what Gridcars used to inform us is where we see this technology is going for the future and how we're trying to position our drives forward. So what does the network really look like? Well, that's it. So every major highway in South Africa is currently covered. Hitten did show a map as well. This shows you where the DC units are, and you'll see there's a big focus of DC units along the highways. And then in the smaller towns, it'll be AC systems. Those 4 yellow pins that you see, those are sites currently under negotiation. So hopefully in the next 2 months, by December, those should be completed, but will depend on the sites themselves. So we are in discussion with the sites for those installations. So this gives you some sense of where it is. 7.4 megawatts of capacity has been installed. And that's across the board in South Africa, is 7.4 megawatts, approximately 340 charging points available. And that's amazing. If you look at the fact that we only have about 1,000 electric vehicles, that means you've got 1 charger for every 3 cars. Worldwide, that average is more like 1 charger for every 20 cars. So we're definitely ahead of this. There's a challenge in that a lot of these chargers stand on their own. So, as Gridcars, we'd love to see other people getting into the market and investing and putting chargers down near or in between existing charging stations so that there's redundancy in this network. So right now, it's a relatively critical run. If you want to go down to Cape Town and you've got problems at Beaufort West or Laingsburg, you're probably going to have to spend the night somewhere. It'll be great if other installers were starting to install multiple charging networks in those areas, and we'd start to see more security that you'd be able to know that you can drive without a problem. That said, we haven't had a problem where somebody has had to spend the night. So we maintain a really high uptime. I think our average uptime is about 98% on this network at this stage. So just looking a little bit further afield than South Africa, certainly we are in discussion with countries well north of the Southern African tip, but these are all places where we're in negotiations now with installations of charging stations. In fact, some of the Zimbabwe ones are in place already, so there's already charging infrastructure being developed in Zimbabwe, and we're working very closely with the team in Zimbabwe to ensure that the right technology is put on the ground, that they've got all of the right billing and management systems behind that, that they're able to deal with what they're working forward with. So consumption, what is the use? One of the March ones, so that's the 5th bar from the left, is 2.4 megawatts of energy, or megawatt hours of energy that was transferred in that month. That was pre-lockdown. So the next one, which went to pretty much to 0, was lockdown for South Africa. And as you can see, by September, the second bar from the right-hand side, we had already broken the March record again in terms of consumption. But just to put this in perspective for you, firstly, this is any charging that happens at the dealerships like BMW, Nissan, Jaguar, etc. It's only public charging network, the fast charging network that's been looked at for these statistics. Secondly, what is 2.5 kilowatt hours or 2,500 kilowatt hours, so 2.5 megawatt hours, what does it really represent? It represents about 15,000 kilometers of driving per month. More importantly, remember, we spoke earlier that really we believe that only 10, 15, 20% of charging. So if we take that into account, this means that there's well over 100,000 kilometers of electric driven every single month in South Africa, just based on the projections that we're working with. We do suspect that we are vastly underquoting this. We think it's probably 3 to 4 times higher. And part of that is that the market doesn't fully understand that there are chargers. I've spoken to people owning electric vehicles, and I said, you know, you can drive to Cape Town. They say, oh, no, you can't. It's an electric car. And this is a guy owning an electric vehicle. So there is a big role to be played to really educate the public and get them to understand that. Just to put it in differently, you know, 2.5 megawatts on turnover on that network is about 10,000 Rand. That's certainly not the profits. And as you can see, it definitely doesn't break the bank. But this is the start. And it's something, if we don't have it, we can't start. We really have to see this as the enabler that is going to take us forward. So looking slightly differently at the network, so if we look at the network as to where coverage is, if you see red between 2 places, that's probably where you've got to drive a little bit more carefully. I'm going to zoom in down to Cape Town just to give us some sort of idea in the Western Cape area. So you can see that if you were looking at this, you would need to, driving up the West Coast to Vredenburg, you'd need to be cautious. Cautious means just drive a little bit more carefully because there is a bit of red in that area. So we try to ensure that there's no red across the board. This would be for a vehicle with a range of about 200 kilometers. If we tighten up those ranges and we say, what about a vehicle with only 100 kilometers of range? Okay, now we've got a problem. That vehicle probably won't go from Cape Town to Vredenburg. And we'd really need to look at installing the charger in between that. So this tool allows us to examine and explore and understand where that network is going and how we're working with it. Part of discussing all of this, you know, when we talk about infrastructure, we've spoken now about the energy, we've spoken about the locations and things like that, and we've spoken about the charging points. But there's a much bigger part to this infrastructure. Gridcars has about 28 approved installers across the country that are able to support our network and support installations all over. We also have about 10 Gridcars approved IT support. Charge points are not just pieces of electrical devices. They are intelligent computers. And you need people that are able to support in a very different way to what an electrician can support that network. Furthermore, we've got 41 what we would call drive-approved EV drivers. And these are drivers that we trust, which means when we do an upgrade or a software update to a charge station remotely, we would notify one of these drivers and they would be able to go past their charge station and just make sure everything's fine for us. So it allows us to a really wide footprint to manage a much broader network. We've also established an office down in Cape Town because obviously there's a lot of charging down there, and as time goes, we'll expand that, that penetration into other markets. So infrastructure is a lot more than just the things on the ground. It's really that network and the skills and the education that we've had to put across that. That was highlighted earlier in the talk around Kenya. So these are all of the charge station rollout partners that we've been working with throughout South Africa. So as you look at that list, you'll recognize names like Sun International, Growth Point, Shell, Pareto, National Parks, all of these different areas. These are all sites that have installed charging infrastructure to some extent, or that have partnered with us to roll out charging infrastructure. And, you know, I heard somebody the other day and he said, yeah, but the fuel companies aren't on board. We're saying the fuel companies are all on board. They all understand and they all take it forward. So thank you so much. You're welcome to contact me. These are my contact details. You can see where we've been. It gives you some examples of the sites. You're welcome to contact me directly, or there's my telephone number. Thank you so much.
Thank you, thank you, thank you, thank you. Thank you, Godfather, who doesn't want to be called the Godfather. Thank you very much, Winston, for that highly informative presentation. And I think, yeah, I definitely am a bit behind on information. Yeah, when I last checked, you guys, yeah, I think you had about 15 charging stations. So to see that you guys have gone up to 28, that's really, really, really exciting. And I hope that some of the people attending the session are listening very carefully to what you're saying, and they are taking it into perspective and consideration, and they're thinking about how they could install some charging stations in between the charging stations that you guys have, so that, you know, that one, we could increase the competitiveness, and then also give drivers of electric vehicles some flexibility so that they can move from the one to the other without having to worry. So thank you very much for that presentation, Winston. And yeah, good luck on the rest of your journey with grid cars. Now, it is time to move over to our next presenter. Our next presenter in the session is Mr. Carl Steyn. Mr. Carl Steyn is a PR tech engineer, a PR technie engineer, a CEM, which is Certified Energy Manager, CMVP, Certified Measuring and Verification Professional. He's also a senior consultant on energy performance verification, who previously managed the measurement and verification, or M&V function, for 8 years at Eskom. Right, he is acknowledged by the USA, the Association of Energy Engineers, as a certified energy manager since 2002, and a certified measuring and verification professional since 2006. Right, he's registered with the Engineering Council of South Africa. Right, he is an M&V technical assessor for the South African National Accreditation Systems, which is SANAS. He is the president for the South African Association for Energy Efficiency, which is SAEE, and board member since its creation in 2002. He is a board member of the Measuring and Verification Council of South Africa, the MVCSA, and he sits on the Eskom M&V Steering Committee. The SANEDI, Energy Efficiency Evaluation Committee for 12I and 12L tax incentives. He is the SANUS M&V Special Technical Committee and the SANUS Energy Management Systems ENMS ISO 50001 Certification Technical Committee. The SABS ISO 50001 Energy Management Technical Committee, right, which is 242, and he participates in the Clean Energy Ministerial. Wow. Oh, this guy literally sits on every board that I've ever heard of that has to do with energy efficiency in South Africa, and energy regulations. Right, he's the Global Superior Energy Performance, right, CEM GSEP Partnership and M&V Task Force. He is a member of the South African Institute for Electrical Engineers, which is the SAIEE. Right, Carl has been active in many capacities in the energy and climate change field since 1992. So without taking any more of his time, I would like to hand over to Mr. Carl Steyn.
Afternoon all. I'll be presenting on the cleaner transportation, and I've got a huge problem. Typically when we think cleaner transportation, we think of electric passenger vehicles like a nice electric car. The reality is that it's not the major use of liquid fuels in this country. So cleaner transportation is certainly not about electric vehicles only. I'll prove that via presenting the following. I'll touch on something initially for you to think about. Then I'll touch on the focus of this presentation, but essentially it will include various transport options, and then briefly touch on transport innovation. I'll give you some cost comparisons and technology ratings, and then capital cost per mode of transport, and then I'll summarize and conclude. Let's think about something. In 2016, South Africa sold that amount of liters of diesel. That's a huge amount. Certainly, if you calculate the amount of carbon due to the emissions of that diesel use, get that amount per liter of diesel. If you then calculate the total amount of emissions, you get to 31.9 million tons of CO2 per annum. If you can save all of that, then the total carbon tax, if it was applicable to all of that, would be 3.1 billion rand. It certainly is not a fair comparison because not all of it would be applicable, but it certainly gives you an idea. The reason is diesel engines is at best 30% efficient, and that's the stuff we use on our roads. You see it everywhere in vehicles and in trucks and other types of transport. I'll touch on that. The focus of this transportation is based on research that was done for the Chamber of Mines, and it looked at all the transport options, the feasibility and application of each option at various distances, the evaluation matrix, any other innovative technologies that needs to be investigated, and I'll touch on that as well. So certainly an interesting environment. I'm not going to go in detail here, we know most of this, but this is the various types of transport, and this is the one that's usually being used in South Africa at the moment. Normal diesel trucks with huge cargo loads, and certainly there's innovation in that space as well with concept vehicles and the like. But these are not the focus of the presentation, but it needs to be taken note of. Other transport modes, as for the systems being used in the rolling industry, as well as road trains in the Northern Cape areas, and certainly there's developments there as well, but the RTNS system is one of them. Certainly it's an area to note as well. In the normal conventional rail methods, that's Transnet and the likes. There's various types of freight there as well, but certainly you get the picture which needs to be considered. Often many of these railway lines are electric driven, which is good, but many of them are still driven with diesel locomotives. There's transport options, and some of them that's innovative and being investigated, and some already in use, is the magnet systems, the experimental magnet systems. These systems are far advanced because of the fact that these systems, the rail magnet system for rail purposes, transporting personnel or people, is operational in Shanghai. And then normal conveyor systems and pipe conveyors where you form, this is a thrust conveyor, a pipe conveyor is where you form a pipe or with the conveyor itself. Comes an option as well, we know this one well. Then other transport options is we transport the product in a slurry form, we crush it and we mix it with water or something else, and we pump it along a pipe or something similar. The other transport option is product locks, where you press the product into locks and you push it into a pipe, and then you drive it on in that pipe. It could be with water, it usually is in this instance, if the product won't dissolve in the water, or you can push it into a pneumatic capsule or liquid capsule. This one is well known and already being used in water. These are brand new. This is the picture from Elon Musk website. Other transport options is bimodal systems or combination systems. This is where you use the container, don't even remove the wheels, you just load it on the rail as is with using a technology like this. In these cases, the container could be open at the top or closed at the top. Take note of this one. It's an important picture, and I'll touch on this quite often during the next few slides. This transport option is a combination of a rail system and a conveyor system, where you have a rail buyer, tried and tested, lots of them installed were required, and certainly quite easy to fathom understanding how it works. but certainly take note, it's similar to a conveyor system, but it's really carts on the track. Also, a well-known system, this is actually transport systems that could be classified as ancient, because many of these types of railway systems exist since the late 1800s and early 1990s. The aerial ropeways and also the rope conveyor systems. These are usually used in forest areas or valleys and mountains or mountainous areas, or ropeway systems are being used in Barberton still. And we've got South African suppliers for all of these. Innovative transportation concepts that's currently being driven, and green hydrogen is probably the most important one. And green hydrogen is where you generate hydrogen from the green energy like EV and wind, and we've got huge amount of solar in this country, so this is an area where South Africa is seriously doing some research in. And there's also a possibility of using platinum cathodes and electrodes to generate hydrogen, and therefore so platinum is also being used. It would be hugely beneficial for South Africa, and there's lots of interest in this space. Then there's also work being done on autonomous vehicles, self-driving electric buses. I don't know if that will work in South Africa. I think so, but certainly might not be the appetite considering the amounts of joblessness in the country. And then there's work all being done on conversion kits, but more work is required specifically in South Africa, because why throw away an old vehicle? When the engine seizes or something happens, why can't we convert it to an electric vehicle or a hydrogen vehicle? We need to start getting these things allowed. Transport sharing is becoming a big drive, because why should my vehicle stand in the garage all day, every day? Even if I'm at the office, it just stands there. Nobody uses it. Transport sharing is really the ideal solution with green energy sources. They're not automated and autonomous drones. There's a picture of a drone in the Hyperloop system that I've had a picture and discussion on as well earlier. The overhead bogie systems, which is also being developed in South Africa. Then there's work being done on satellite-based traffic control systems, which is automated. And elevated buses, you really get these in China, where the vehicle straddles the traffic. Looking at cost parameters, and this is based on rough order of magnitude principles. It includes the capital and operation and maintenance costs, but it does not provide for any escalation on maintenance costs. It's also based on the annual throughput of 5 megatons per annum, with a life system or financing period of 20 years, a capital interest rate of 10%, and a unit cost of rand per ton per kilometer, and then lead distances between 1 kilometer to 1,000 kilometers. Let me show a visible representation of what I just said. This is a graph of all the technology, most of the technologies that I've mentioned earlier. And looking at this graph, you can see where they all perform at. Look at the railway system. That's why I said look at the railway system and take note of that technology. It's the most cost effective in all distances. It's the only one that's most cost effective. But you can also see where the others fits in. And of course, there's a huge amount of very interesting data hidden up here on this graph. But certainly this represents and gives you an idea of where we can look at for technologies. For shorter distance, looking at the first distance, unit cost per mode, 1 kilometer to 10 kilometers. This shows you the various graphs, and the railway system, as I've mentioned, is the most cost-effective, with ropeways or normal conveyors coming in very close in here, and then rail trains also fitting in there, depending on the specific distance and the tonnages involved. If you look at the cost comparison for short distance, 10 kilometers, with various scenarios, 1 megatons per annum, 5 and 50 megatons per annum. You can see railway systems with conveyor system is the best rank, but it depends on tonnages. Remember that? Tonnages. So certainly railway features quite well again, but you can see the ranking for all technologies. Sorry. Looking at the distance between 20 kilometers and 200 kilometers, you can see the railway is still there, but now road trains and product lock pipes and road conveyors comes in as well, quite competitively. So certainly, depending on the distances and the tonnages, you need to consider these technologies that are most cost effective. Looking at the specific graph in a table format at the various scenarios, again, 1, 5 and 50 megatons per annum. Depending on the tonnages, heavy haul rail is ranked number 1, with railway number 1 for 5 megatons, and then the normal conveyor system on 50 megatons. So the conveyor system still features, and that's why conveyor systems are often used. But often you still get trucks being used where a conveyor system or other technology can be an excellent replacement. With product lock pipes are the best rank, and the rest of the rankings are available. Looking at the capital cost per mode of transport, let me pick a few just to go through. Look at railway system. The system, the cost is system dependent, the infrastructure cost, but typically it's on average 13 million rand per kilometer, and you need the vehicles on that system, the railway system, that's the COT, which costs on average 2.5 million rand per train set. This is not 2009 information. Looking at overland conveyor system, it's system dependent, but on average between 20 and 30 million rand per kilometer. Quite a huge difference between this and this, the infrastructure cost, and you have no costs. So there's a cost component that you save there as well, and also that goes less maintenance. Looking at the product lock pipe, the pipeline throughput is it's throughput dependent, and the minimum cost is around about 2.6 million rand per kilometer, and you don't have any vehicles. But we do have a water problem in this country, so you need to consider that, and you will do that or use that as well. Very competitively priced. So this gives you a cost estimate for the infrastructure and the vehicles involved in setting up a transportation system. In summary, railway system is the only technology with a competitive transport cost across all distances. The latest diesel carbon tax liability, which is 10 cents per litre paid at source when you purchase the diesel, is considered in the aforementioned calculations. I've included. Diesel truck transport options is usually considered, and often these trucks run at a 50% no load, because it goes to one side empty to load, and then it's loaded, and then it goes back with the load and offloads the load and travels back. Yes, you can argue that the conveyor system goes back empty as well, but remember the amount of load that you take back in a conveyor system is minutely small compared to a huge truck that needs to travel back. And so you use lots more energy for traveling on with no actual valuable load. The quality of load services will have an impact on trucks, and it's not being considered in these calculations. Electrical transportation options are often most competitive, more so than liquid fuel solutions, both in operation and in capital cost. Remember that carbon scope 1 is not part of a facility because it's a scope 1 impact. So carbon tax not applicable to a facility. There's further investigations required, especially for the feasibility for technologies of a lead distances beyond 100 kilometer. Make sure that you know what the possibilities are and what the cost would be. Where railway systems converge into one main line, we need to do some investigation to ensure we do that correctly and automatically. You will need to investigate detective infrastructure systems for unmanned and automated systems. So many of these systems can be unmanned and automated. Then alternative solutions lies in the effective combination of all technologies, integrated and well managed in a network. Apply the best technology for specific distances and environmental conditions. We don't have a choice anymore, we need to do this now. Introduce intermodal transfer stations, hubs, entries in island terminals where necessary. And additional investigations is required in total hub cost. These hubs and stations that's created, the cost is not included in this presentation. In conclusion, freight and raw materials transportation combined use more fuels than passenger vehicles, especially now with most people working from home. New options are being developed continuously, and we've seen that, especially in the exciting area of green hydrogen. Many of these options are more efficient, it's tried, tested, and they already exist. The uptake of the most suitable transportation options should be promoted. Promoting technology change with factual and research findings, that's the easiest way to do these things, and that's why I present this. Users to consider the most efficient transport option. Not just take a truck, that's usually what happens. I'm in the transport business, so I must buy a truck. Further research is required, as I've mentioned, there's quite a few gaps. We need to look at opportunities for cleaner conversions and new installations. And develop and implement more innovative solutions as well. We need to identify funding opportunities for conversions and new installations. Innovative funding initiatives will drive some of these conversions. I'm in the market for electric vehicle, but they're too expensive. But the whole life cost of the vehicle is very reasonable. Why can't I afford that car? Somebody needs to come up with a solution. It's the same for the industrial sector, where most of the technologies that I've touched on today is applicable. The technology suppliers need to provide assistance to ensure technologies are available and at a credible cost. Some of these technologies are not available in South Africa, and we need to start getting them more available, then the cost will become lower. Policy and regulation. In this regard, government needs to consider implementing regulations to drive the uptake of most efficient technologies, drive transport from diesel consumption to rail conveyors and etc., and incentivize innovation. Many years ago, I remember trucks could only travel for a certain distance with loads on them, and then they had to offload. I think it was a distance of 75 kilometers or something like that. Many truck operators created stations at 75 2-meter intervals to bypass that regulations. But they could only do so if it was 150 or 160 kilometers apart, because then they can create one such intermediate offloading station. For further distances, it was better to just move to rail, and that's why rail did quite well in the past. Perhaps we need to look at that again, especially where electric rail is possible. Exciting times. Certainly, thank you for your attention. We'll discuss any questions now or during the session later on. Thank you. Bye.
Thank you, Mr. Karel Steyn, for that highly informative presentation. All right, now we're going to move to the discussion session where we will get an opportunity, or I'll get an opportunity, to share some of the questions that have come in from some of our viewers with the speakers, and getting some answers from them on those questions. We are pressed for time, so I'm going to pull out my whip on the speakers when they are responding to those questions. Okay, are all the speakers on? Hey, Simon, how are you?
Sorry, I
can't hear you.
Yes, very well, Brian. Good to see you again.
Hey, nice to see you. Nice to see you. Okay, Simon is on. Highton, are you on?
Yes.
All right. Carl, are you on?
Yes, I'm on.
Okay. And the Godfather, are you on?
I'm on, but for some reason it's blocking me from starting my video. I don't know if you can release it.
Okay. I'll ask the tech guys to have a look at that. In the meantime, because we are very, very short on time, I'm going to throw the first question. And the first question goes out to you, Simon. Okay, question 1. Has the battery waste stream been considered? Now, I don't know if you want me to throw the question, then you answer, or... Yeah, actually, I think because of time, let me throw the question, you answer immediately, then we can move on to the next question.
Okay, thanks, Brian, and thanks for the question. We are, of course, as you have noted, in the very formative stages of putting together this infrastructure for e-mobility in Kenya. So we literally do not have a charge right now for waste batteries, but we are, of course, looking to bring in partners who will be helping us with this. And that's the reason why the putting together of the association became very important, in that we will have the entire value chain and considerations for each part of those value chains are accommodated by the association. So yes, we're looking at people who will come on board and who will help us with recycling or even repackaging the batteries for use at home, whatever it is that is going to be needed. Thank you.
Thank you, Simon. And yeah, that's a very good point on the recycling of the batteries and using them at home. I see that's a very popular way of reusing vehicle batteries in the US and in the UK. All right, we're going to move on to the next question. And this question is going out to Mr. Highton Palmer. Right. Yeah, I've got 3 questions. Actually, all 3 of them are really exciting. So I'm going to try and pick one due to time. Okay. All right, let's go with this one because, you know, we speak in South African context. We look at job creation, job opportunities, right? What is the plan regarding service centers for electric vehicles? Will existing vehicle service centers upskill to support electric vehicle servicing?
Thanks, Brian. So certainly, I think, you know, from a dealer perspective, they already have already undergone training on all the critical staff and upskill them on high voltage training. And certainly that's been within the dealer network, and obviously because of the new vehicles being introduced, and mostly within still in warranty. However, outside of that, within the retail dealer network, that's where some of the discussions are currently in play, and skilling of workforce within the retail network.
Okay, thank you for that response, Highton. And if we do get a bit more time after asking every presenter one question, I will come back to you with one of the other questions. Okay, the next question. I'm going to throw this question at Mr. Carl Steyn. Even though the person who had asked it had wanted Highton to answer the question, but I think Mr. Carl Steyn would have a bit more information on responding to this question. And the question there, Carl, is what is the emissions impact for South Africa if EV penetration is faster than coal-powered plant replacement, resulting in higher emissions from the charging of vehicles using coal-based electricity?
Thank you for the question. The fact of the matter is that you can control emissions much better at a central location. So especially the new power stations we have, the technologies are installed to manage emissions, and you can also generate with renewables and use renewables in the grid to charge vehicles, electric vehicles. So certainly there's huge benefits in going the electric route. That's only looking from an emission side as per the question. There's many other benefits, and Winston touched on it, and Ethan touched on those as well. And that's why most of us are looking for the EV.
Thank you, Mr. Carl Steyn. All right, the next question, I'm going to throw this at Winston. Winston, do you think South Africa will be able to get ready for e-mobility as quickly as the Western world is moving, to be able to prevent Africa, and in this particular case, more South Africa, from becoming the dumping ground for fossil vehicles or fossil fuel vehicles?
Well, it's a very, very good question. And I think, firstly, a dumping ground, it's hard because we don't allow the importation of second-hand vehicles. So there won't be necessarily dumping for South Africa. Rest of Africa, absolutely, that becomes a real challenge. The real thing, though, is that once we pivot beyond vehicles being, let's say, price parity between electric and fossil fuel vehicles, then the business case for getting a free fossil fuel vehicle but paying for petrol versus getting a paid for electric vehicle and paying for electricity is cheaper for the electric one. So it's actually almost nonsensical to even take a free petrol vehicle and try to drive that. So absolutely, I don't think we can become the dumping ground. The problem is, are we going to have a problem? Absolutely, because our adoption rate is too slow. So if with the slow adoption rate, it means we're going to get to a point where suddenly the manufacturers are going to say, sorry, we no longer have petrol cars available for you. And there'll be a massive shortage of electric vehicles. We'll be desperately trying to buy second-hand vehicles that are already in South Africa. So I do foresee a lot of challenges unless we can find a way to stimulate this market and get electric vehicles moving in this market and start to replace vehicles, that when that pivot happens, it will be quicker than we can handle it. It will be disruptive in our market. And if it happens as quick as some of the more optimistic times, which are saying 2026, there will be no longer fossil fuel vehicles available. Now, that's the most optimistic, but it's not unrealistic. There's a real potential of that happening.
Thank you, Winston. All right, we still have, I would say about 5 to 8 minutes. So I'm going to try to squeeze in some more questions. I'm going to start with our international guest again. And the question for yourself, Simon, is there information on how many BEV and HEVs are currently operating in Kenya?
Sorry, Brian, come again.
Okay, the question is there information on how many BEV and HEVs are currently operating in Kenya?
Okay, first and foremost, Brian, as you saw, we have only about 200 units, just under 200 units in Kenya. I'm not very sure what that nomenclature is about, but we have the industrial scale, we have just a few forklifts and one tractor. The others are two-wheelers and three-wheelers, and the vehicles are just about 15. So we're just beginning here, and we do not expect, as Winston has said, we do not expect that we will be allowing to become a dumping ground. But we also have begun to see people wanting to sell off second-hand e-vehicles into Kenyan market. So we may see an acceleration beyond what we probably thought before. But all this is going to be driven by the availability of the infrastructure. Thank you.
Thank you. Thank you, Simon. Okay, we're going to squeeze in another question. Which one do we go with? Okay. Okay. Highton, this question can go to you. But what steps could be taken in the mainstream V2G applications from a regulatory perspective?
Yeah, so from a regulation perspective, the interesting scenario in South Africa's case is the advent of load shedding, and through that, it's allowed typical small-scale embedded generation and also feed-in tariffs as and where that's allowed. So, especially in the grid code, it relates to the inverter that connects and disconnects to the grid, and within that, there's also the parameter within that. And on that classification, it's not too concerned from a regulatory environment where that energy is coming from, as long as the device connecting to the grid complies with the connection and disconnection. So at least from that perspective, the onset of renewable energies has created a favorable environment for vehicle-to-grid technology. The only aspect comes in from the central management from a pricing point of view and how that gets managed. But there's a business case behind that. If I can also just comment on the earlier question around emissions. So with the earlier report that was done on the macroeconomic study in South Africa for electric vehicles, so currently within South Africa, we have Euro 2 fuel quality, which is 15 years behind the global market in the context of Euro 5 and Euro 6. And with that study in consultation with multiple stakeholders, if South Africa was to transition on fossil fuel vehicles from Euro 2 to Euro 6, it'll only provide a 14% saving on greenhouse gas emissions. If South Africa was to transition to electric vehicles and charge through the current Eskom carbon-intensive grid, it will provide 34% saving of greenhouse gas emissions. However, if we were fully to transition to electric vehicles and charge through renewable energy, it will provide 67% reduction in emissions. So just feedback on that point raised earlier.
Wow, thank you. Thank you very much for that information, Highton. Okay, we still have a bit more time. The next question, I'm gonna go back to Winston, right? And the question is, are there any local EV projects or companies you are excited about outside of grid costs? So are there any other new players or projects in the EV space in South Africa that you've looked at and thought, wow, now we're going somewhere?
Definitely. There are more and more people building new networks. Without naming names, because I think it's not appropriate, but certainly the big oil companies are driving to push forward on networks. Certainly more OEMs are planning to bring products into the country. That's always exciting. I know of at least 3 local manufacturers looking to manufacture some sort of vehicle in South Africa. Anything from tuk-tuks up to bakkies and vehicles. So I think there's some exciting projects coming through those lines. They're difficult though, you know, without getting government, especially South African built vehicles, you know, we've seen a few of them rise and fail. And, you know, that's mostly due to lack of funding. So, you know, are we ready as South Africa, as the government, as the banks, to back these guys and help them to get going? I think that's the real question that we need somebody else to answer. But yeah, I'm excited about lots of projects happening. And as I say, definitely local charging station installers. You know, we've spoken to a few of them. It's great to see them on the road and see them starting to put chargers up. Most of them are displayed on our map as well. So we've already made roaming agreements with them. So if you have a Gridcast card, you'd be able to, or in fact a BMW card or a J, you'd be able to charge at any of those networks, because all of them are already being represented through that one system. So I think that for me is the exciting part of that.
Cool. Thank you very much for that. I see that the countdown timer has started, and that's making me a bit cautious on whether I should throw another question into the field or wrap up the session. So to play it on the safer side of things, I'm going to try and wrap up. Gentlemen, thank you very much for the information that you shared with us today. I think I'll use this last minute or less just to touch up on some of the stuff that or some of the information that you guys have shared with us today. Simon, thank you very much, all the way from Kenya. I'm definitely excited about the opportunities that you have in Kenya for the EV market. And I think, you know, I was planning to go to Nigeria for my next holiday early next year, but I'm going to try and swing my friends to go to Kenya so that we could look at some of the opportunities in that EV market, you know, and get a bit of best of both, make some money and also, you know, have fun as well. Then we were presented to by Mr. Highton Palmer, right, from who's done a lot of work in helping develop the South African EV market. I've seen a lot of exciting projects on your Uyilo website. And yeah, time-wise, no, it's not gonna work. Guys, thank you, everyone else who presented today. Cheers.
Thank you.